In this lesson we're going to discuss flip-flops and what they do and the different circuits and the truth tables and timing diagrams associated with flip-flops. So flip-flops started out with the SR flip-flop, the set reset flip-flop, and they started out by just making them out of NAND gates and NOR gates, and we'll look at the NAND one next. And the cross-coupled NOR was one of the first ones that were ever made. And what a flip-flop does is, if you looked at the lecture notes, you see that a flip-flop actually stores a binary piece of information. You can either store a high or store a low, kind of like a little memory address in like a computer, but it only holds one bit. And what we can do with that is we can keep it stored there or saved there either until it gets changed or until power gets removed from the circuit. So one of those two things is the only things that's going to take away that, that setting. So let's look at this SR cross-coupled flip-flop. Let's make a little truth table for it. So we've got S, we've got R, and we've got Q, and Q naught. Now remember, Q naught should just be the opposite of Q. It should just be the inverse of whatever Q's doing. So we've got 0, 0, 0, 1, we'll count a binary, and 1, 1. Now when I go through this, I'm not going to actually do it in binary because you'll see why it makes more sense. But I'll show you what mode it's also in. So let's start out by setting high on a set and a low on the reset. Now this particular flip-flop is what's called an active high. In other words, it takes a high to activate that input, or it takes a high to set this flip-flop. There's also ones we'll look at later called active lows that take zeros to activate them. So in this case, there's no inverters out here, there's no bubbles, so it's an active high input. So what we're going to do is a high, low on reset. So a high on set, a high going into this cross-coupled NOR, into a NOR gate, a high into a NOR gate. If you kind of think of it as an OR with an inverter, or if it's an OR gate, any high gives you a high out, right? So 1 into the OR gate gives you a 1, inverted to a 0. This 0 is getting fed back here to here. 0 or 0 gives you inside, like I said, just an OR, gives you a 0. You invert that to a 1. 1 gets fed back here, 2 highs still gives you a 0, 2 lows gives you a high, and that's our output. So if S is high, reset is low, we get a high on Q and a low on Q naught. Let me put a line here to kind of divide this up a little bit better. So you've got a high on Q, low on Q naught. This is called the set flip-flop. And one note, anytime you set a flip-flop, Q goes high. Okay? Anytime you set a flip-flop, Q goes high. Now that setting may happen with a high or a low here, we don't know. But anytime you set a flip-flop, Q will always go high. So set it, goes high. Now let's change this. Let's say that S now goes to a 0, okay? So we were set, now it goes to a 0. So we've got 2 lows. We've got a 0 and a 1, 0 ORed with a 1, I should say. 0 ORed with a 1 is still 0 out here. 0 getting fed back here is still 1 out here. 1 still getting fed back, still gives us a 0 here. So nothing changed, did it? Our input went to a low, 2 lows, but we didn't change our output. So basically, if they're both low, Q stays Q and Q naught stays Q naught. This is what's called a hold. And hold means you've stored that information. In other words, we've set the flip-flop, and then we can go to a neutral state. In other words, where we're not setting or resetting at all. It's just holding position. So we're going to keep whatever was there, there. Okay? Next, let's say we reset this flip-flop. And to reset it, we're going to put a high here. So a high and a 0 now. Instead of a 0 here, we've got a 1, which inverts to a 0. 0 is getting fed back here. 0 ORed 0 is 0, which is now a 1. 1's getting fed back here. 2 1s gives us a 0 out. 2 zeros gives us a 1 out. So now you can see that we kind of switched places. That became 0, that became a 1. This is called a reset. And it kind of helps you think about it. Remember, like an egg timer or a kitchen timer, if you hit reset, what does it do? It usually goes back to 0. So reset, Q goes to 0. And you can make that another rule. Anytime you reset a flip-flop, Q goes low. Okay? So anytime you set a flip-flop, Q goes high. Anytime you reset a flip-flop, Q goes low. Always and forever. Never change. Okay, so I've showed you the set, showed you reset. What happens if this goes back to 0 again? We've got 0 and 1 stays a 0. 0 or 0 stays a 1. 0 or 1 stays a 0. Nothing changed. So that was our hold mode again. In other words, we reset it, then we went back to the hold state. In other words, stay what you were doing. Now where it gets weird is if we tie them both high. And if we tie this one high and this one high, we've got 1 and 0, which is a 1, which is now a 0. 0 fed back here, it's still a 0, right? 0, 1, still 0, 0. So we've got both outputs are low. Well, if, like I said at the beginning of this, Q and Q naught should always be the opposite of Q. Well, if they're both low, we got a problem there. So what we do generally is for SR flip-flop, that's a weakness of theirs. It's an undetermined, an unused input. Don't ever do 2 highs on a reset flip-flop. So this is do not do. Do not do that. It's the reason being is, think about it, if you set your kitchen timer again, if you set it for 10 seconds and you're trying to hit reset at the same time, well, you can't set something to 10 seconds and reset it back to 0 at the same time. It's impossible. Next thing we're going to look at is the cross-coupled NAND flip-flop. And what we have to do to make it line up right is we have to put these inverters there. Makes it look a little bit easier. Again, the truth table for this is actually going to be the same. You got SR, Q, and Q naught. But I just want to run through this real quick. The modes are the same. When we hold, so Q and Q naught stay the same. This is going to be a reset, so this is 0, that's 1. This is going to be a set, so that goes 1, that goes 0. And this is our do not do. Okay. So if we put a high, let's say we put a high on set, a low on reset. Well, we know that Q should go high. So let's look at it. We got a 1 inverts to a 0. 0 inverts to a 1. Well, can't really figure out what's going to happen here because 1 and whatever, we don't know. It depends on what this one is. But I know for a fact that if I put a 0 into an AND gate, the output has to be 0, right? Invert that, since it's the NAND, goes to a 1. Now we can figure out what this one is. 1 and 1 is a 1, which is a 0. 0 fed back here is still 1 out. 1. So see, we set the flip-flop, Q went high, just like we should be. Hold is hold. I'm going to let you know that. Reset's reset. Everything's the same. Let me show you what happens if we go to 2 highs. We got that inverts to a 0. That inverts to a 0. That now becomes a 0. That becomes a 1. The 1. We still got a 0 here. So basically, instead of 2 lows, we ended up with 2 highs. So it's still an invalid condition. In other words, Q and Q naught still can't be the same, but so we still have that problem. So it's still a do not do situation with S and R. If I ask you any of these on a handout, it will probably be more, I give you the inputs, you have to tell me what the outputs are. It's not going to be filling out a truth table or anything. It's just going to be, here's the inputs, what's the outputs going to be. So you kind of get it from there. So let's do some timing diagrams. And timing diagrams, if you remember, we kind of discussed them in the notes a little bit, but timing diagrams are a way to represent signals over time. And we're just going to go with a basic SR flip-flop. And I gave you the truth table up here. 2 lows is just holding. A high on reset resets at a low. High on set sets at high. And 2 highs gives you a do not do. And I try not to give you any of the 2 highs in here because we don't want to do that. So for this section right here, we're looking at this section and this section. We've got a low on set, a high on reset. Well, a low on set, high on reset gives you a low on Q. So it's going to be low over to there. Next we've got a low and a low. Well, 2 lows is just a hold, right? So this is going to reset. This is going to hold, and it's going to hold right there. From here to here, we've got a high on set, low on reset. So a high on set, low on reset is a high on Q. So we're going to go high right here, and it's going to stay high all the way over to there. So that's a set. From there to there, we've got too low, so that's going to be a hold. From here to here, we've got a low on set, high on reset, so we're going to reset the flip-flop. And then from there to there, we've got too low, so it's going to hold. And from here to here, we have a high on set, low on reset, so we're going to set the flip-flop. From here to here, we've got too low, so it's going to hold. And remember to get this very last bit of it. From there to the end, we've got a low on set, a high on reset, so we're going to reset the flip-flop. So just take it a section at a time. Anywhere you see changes, like here, then we had a change here, then we had a change here, had a change here, 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 and something may or may not happen down here, but you need to look at each one of those changes. So that's just the basic SR flip-flop. Now what they found out was SR flip-flops, regular SR flip-flops are always changing. Anytime you change the input, the output is going to change. Well, that was at a disadvantage for that two invalid conditions. So what they did was they invented a gated SR flip-flop. And you sometimes will see these labeled a G, sometimes you'll see it EN, which is enable. You'll see it listed different ways. And what that is, they basically took an SR flip-flop and they added these AND gates over here. There's the output of that one, there's the output of that one. And they tied this one to our enable line. And there's our R, and there's our S. So if the enable line goes 0, 0 on both these AND gates is a 0 out. Well, what happens when S and R are both 0? It holds. So it just holds on. So anytime you're not enabled, in other words, you got a 0 on the enable line, we're just going to hold. Q stays Q, Q naught stays Q naught. When it's high, when it's enabled, we follow just like the regular SR. We got a low and low is just a hold. 0 and 1, high on reset is a reset. High on set is a set. High on both of them is a do not do. So really we're only going to look for the areas where the enable line is high. So we basically are going to look at it from here to there, there to there, there to there, there to there, and there to there. So we don't care what's going on between. From there to there, we're just going to hold. So the first question we're going to say to ourselves is, okay, what does Q start with? Well, I'm not enabled, right? We're low. And I'm not looking at set and reset. They're turned off. In other words, we're really looking at two lows on set and reset when it comes to the chip side of it. So we're really disabled right here. There's no way for me to know what Q starts at. So what we do is we do this invalid, don't know kind of line. You put a little block in there to where you put little hash marks to it, and we don't know if it's high or low. It could be one or the other. It's going to be something. We just don't know what it is. There's no way to figure it out from our diagram the way it is. Now we can go through here. We're enabled from here to here. We've got a high on set, a low on reset, so we know we're going to set that flip-flop. So it's going to be set. From here to here, it's disabled, so it's going to hold. From here to here, it's going to be high on set, low on reset, so we're going to set there. And we've got two lows, so it's going to hold right there. We're disabled right here, so we're going to hold. From here to here, we've got from there to there, we've got a high on reset, so we know that's going to reset. And then we've got two lows, which is going to hold. Holds right here for two blocks because we're disabled. From here to here, we've got two lows, so we're going to hold again. Here to here, we're disabled, so we're going to hold. From there to there, we've got a high on set, low on reset, so we're going to set the flip-flop. From here to here, we're disabled, so we're going to hold. From here to here, we're going to be low, we're going to hold from right there to there, right? Two lows. But then here, what's going to happen is we've got a low on set, a high on reset. So for that second half, remember it's looking at it the whole time. For this second half, we're actually going to reset right there. So always be on the lookout for any changes while it's enabled. And then we're disabled there, so we're just going to hold. So if you're confused about that, you may want to rewind and watch me go through that again. Hopefully it kind of makes sense to you. We'll look at more of these as we go along, not necessarily this particular one, but we'll look at more of these and it'll become a little clearer to you. So, okay, then they decided that enable line itself wasn't enough. We needed something more than just an enable line. So what they did was there was no way to to reset or set the flip-flop until it, we had to get an SR input. Well, there's never a separate one that wasn't tied to the enable line. So what they did was they added this asynchronous SR inputs. And these set and reset inputs, these right here, this one at the bottom is called reset. It's got a bubble on it. The set right here with a reset with a bubble on it. These are what's called active low, and they're only activated when they go low. So you can see up here at the top, I've got a low on set, which actually says activate the set input. So we're going to set the flip-flop. And you remember the rule, anytime you set a flip-flop, Q goes high. So in that case, we set the flip-flop, Q goes high. We don't care what's going on with these. They could be doing anything they want to. It doesn't matter what position they're in. We're always going to set the flip-flop when this goes low. When this one goes low, the asynchronous reset, Q is going to go low instantly. It's not going to wait around for enable lines or anything. It's going to instantly reset, so it goes low. When these are high, we just ignore them. They're not even in play. And then we're back to our regular enabled SR flip-flop. A low on enable just holds. High on set sets it. High on reset resets it. Two highs, don't use that. So this one gets a little bit more complicated. We're going to have to start looking at these sets and resets. And the first thing I see is this set and reset, right? This set goes low from there to there, right? And then I've got this reset line right here goes low from there to there. So I'm just going to kind of draw me some dotted lines. And then the enable lines these are high the rest of the time, so I can kind of ignore those. But from here to here, let me see if I can get a highlighter so you can see a little bit better. So from here to here, we're going to be looking at it. From here to here, we're going to be looking at it because we're enabled. From here to here. And from here to here, we normally would be enabled, but look, remember our set and reset overrides this. So this particular one right here overrides whatever our enable line's doing. So we can ignore that enable right there. Then we've got an enable from here to here. And then we got an enable from here to here. So I don't like care about these highlighted areas right here. Okay, let me go back to the pen. And what did we start with? That was a question I asked last time, and we didn't know. We didn't know what we started with because we didn't have any way of knowing what it was previous to that. This time there is a way to figure it out, and we can look at this the set and reset asynchronous inputs, and we know that this set went low right here. Well, remember, if this set goes low, Q goes high, so we know what we start at. We start high right there. And it goes back high right here, but we're not enabled, so we're just going to hold for that section right there. Now we're going to look at our set and reset inputs because we're enabled. And once I've got the highlights, I can kind of just skip from highlighted area to highlighted area. So I've got high and set, low and reset, so we're going to set it right there. And then we're disabled, so we're going to hold. We're set and then goes low, so we're still going to be set. And two lows is just a hold, so it's a set and a hold. Hold because we're disabled. Now we've got a high on reset, a low on set, so we're going to reset the flip-flop. And then two lows is going to hold. And then here we're going to hold because we're not enabled. And here we've got a reset goes low. Well, remember, if this reset goes low, Q goes low. So you can't go lower than low, so it just basically stays low over to there, and I'll call that a big reset. And then here we're actually holding because we're still disabled, right? And then here we're set low on reset, so we're going to set the flip-flop. And then we're going to hold because it's disabled. And here we're going to hold the first half because they're two lows. And then the reset goes high the second half, so hold there, reset right there, and then we're disabled, hold right there. So again, this asynchronous set and reset override the clock, or override the enable line. So no matter what's going on with the enable or the S and R or whatever, if this goes low, we instantly change the output to whatever we went low on. Okay, if you need to look at it again, rewind it, go through it again, and if not, we'll continue on. This is what's called a D-type flip-flop, and basically it's an SR flip-flop that's been inverted. The S and R has been. So you've got S and R, and you've got this inverter right here, and that's called D. And what happens is they're always going to be opposite. So you're either always going to be setting, you're always going to be resetting. If D is high, you're going to set it. If D is low, you're going to reset it. So so basically the rule for D-type flip-flop is when enabled, Q follows D. So when you enable the D-type flip-flop, Q will follow D. And you can see that down here. We're enabled here. We're not enabled here, so it just holds. We're enabled, D is low, Q is low. We're enabled, D is high, Q is high. So let me pick a highlighter up so we can figure out when we're enabled. Well, we're enabled during this part right here. We're enabled during this part. We're enabled right here. We're enabled right here. We're enabled right here. And we're enabled right here. So any changes that happen while we're enabled, we're going to see. If it doesn't happen during those parts, we won't see it. So is there a way to figure out what we start with? No, there's no way to figure out what we start with because the enable is low, so it's holding. Doesn't matter here because it's holding. So we're holding basically an unknown output. So we can just put hash marks in our box. We don't know what that is. It could be high, it could be low. We just don't know. So now we're enabled. Remember, Q follows D. So if D is high and goes low, guess what Q is going to do? It's going to be high and go low. Then we're going to hold because we're disabled. And we're going to follow D. It's going to hold because it's disabled. And then we're going to follow D, so it goes low and goes high. And then we're going to hold because it's disabled. And D is low, so we're going to go low. And you notice we missed the low back here. It didn't go low there. It went low back over here where it's enabled at. So you would miss that if it went low there. Then we're going to hold. Then we're going to go high because D went high. And we're going to hold. And D is high and it goes low, so Q is going to be high and go low. And then we're going to hold. So when it's enabled, during these highlighted parts, might be nice to get a set of highlighters if you want, if you don't already have some. But anytime it's enabled, Q just follows this D input. So go to the next one, and if you need to, rewind and review this one if you need to. This is an asynchronous D-type flip-flop, and we're also adding a new kind of clock to this. And we're adding what's called an edge trigger. And let me show you the different kind of clocks up here. We've been dealing with enable lines that look like either this, which is called a positive pulse. In other words, it's this whole positive area from there to there of the clock. Then they have what's called a negative pulse, which would be the whole negative piece of the clock or enable line. Those are the two without being edge triggered. Then they've added these edge triggered kinds. And if you don't have a bubble, which in this case we don't, this is called a positive edge trigger. And what that does is you've got this clock waveform, and it's only on this positive going edge that it's going to enable. So it's kind of like a snapshot, kind of like if you've seen a strobe light, it takes a little like flashes of light. It's only on these positive edges where we're going to be enabled, not the whole positive or the whole negative. It's just on the edges. Then you've got the mouth again, which means edge, and you've got a bubble. The bubble means negative edge triggered. Okay, and the negative edge trigger is the negative going or the downward going clock edge. So it's only on the edges. So when you look at my truth table, you'll see that I've got a positive edge here. I put these little arrows up, meaning it's the positive going clock. Now, if you've got SD and RD, which is our asynchronous inputs, these, remember, override whatever clock you have. So if this goes low, you immediately set the flip-flop. If RD goes low, you immediately reset the flip-flop. So you set and reset the flip-flop regardless of what Q and D is doing. If these go back high, we're looking at our regular truth table. If it's not a positive edge, in other words, it's anywhere but the positive edge, it's just going to hold. On the positive edges, if D is low, Q is going to be low. If positive edge D is high, Q is going to be high. So in this figure one, you can see RD stays high the whole time, so I can ignore that one completely. SD went low just at the very beginning, just to give us a startup condition. Then we can do, again, let me pull up a highlighter. Now we can just look at these positive edges. So really, we only care what's happening there, and there, and there, and there. Just that positive going edge of that clock signal is the only place we're going to look at it. Okay? And change back over to pin. So you've got these positive edges of these clocks. Bring you a little dial line or a highlighted line or whatever you want to do to indicate that. So the flip-flop, this D type, we can figure out SD went low. If SD goes low, remember, it resets the flip-flop. So we're going to be set all the way over to that first positive edge. On this positive edge, Q is going to follow D. So if D is low right there, Q is going to go low. And it's going to stay low all the way over to here, because if it's not a positive edge, we're just going to hold. Or this is a hold condition. Positive edge, D is low, so we're going to go low and stay low all the way over to there. Right there, D is high, so Q is going to go high. And it's going to stay high all the way over to there. D is high, so we're going to stay high. D goes low here, so we're going to go low. D is low, we're going to stay low. So these are great. I love edge-triggered flip-flops because we're not having to worry about this whole positive pulse or the negative pulse. We can just look at these edges coming down. It's just like little snapshots of the wave, the inputs. Just taking a snapshot, figuring out what it's going to do. Take a snapshot, figure out what it's going to do. So it's a much quicker way of going through these. There's another type of flip-flop called a JK flip-flop. And you remember I said one of the limitations from SR flip-flops was this: anytime you tried to set and reset at the same time, you got an invalid condition. Well, what JK flip-flops do is they overcome that by creating a new mode called a toggle mode. And all toggle mode does is it inverts whatever Q was over to a Q naught. In other words, if Q was high, it's going to go low. If Q was low, it's going to go high. So if it was high, it's going to just invert down to low. You'll notice these are edge triggered, positive edge. So if it's not positive edge, it's going to be just a hold. Positive edge, they're both low, it's going to hold. Low on J, high on K is going to reset, and you kind of think of K as a clear. High on J, low on K is a set, and two highs is a toggle. So let's figure out how this actually looks when we do our waveform. And again, we don't have any kind of SD or RD, so we don't know what our initial condition is going to be. We can figure out we got positive edges. So got a positive edge there, positive edge there, positive edge, positive edge there, and a positive edge there. And so we don't know what this starts at, since we have no idea of knowing what it was before that time. So we just have to do an I don't know, undetermined value. Now here we're going to look right at that instant right there. So J is high, K is low. That's a set. We're going to say set all the way over to there. Now we've got two lows, so that's going to hold. So this is because of J. This is going to hold. Now we've got a low on J, a high on K, so it's going to reset or clear. I want to think of it that way. That's because of K. Now we've got two lows, so it's going to hold. We've got a high on J, low on K, so it's going to set or go high. That's because of J. And here we've got a high on J and a high on K. Remember, that's a toggle mode. So if the output's high right now, it's just going to toggle or inverse to a low. So that would be our toggle mode right there. So remember, just snapshots of what J and K are doing at those instances, which is great. So I'm going to go on to the next one, and you can rewind if you want to look this over or pause it, whatever you want to do. Go on to the next one. Same thing. I just want to do another example. So again, we have no way of knowing what it starts at, but let me highlight all my positive edges here. So we know where to go. And we don't know what it starts at, so we can do this undetermined box right here. We don't know. Next one, we've got a high on J and a high on K. Okay, that's going to toggle. We don't know what this is right here. So we're going to toggle an unknown. It will flip states, but we just don't know what it flipped from to go to. So we'll just do another box, basically, because we don't know. We have no idea of knowing what that is. And now we've got another edge. So we've got a low on J and high on K. So we're going to reset. Two lows is a hold. Hold. That's because of K. Now we've got a low on J, high on K. We're going to, again, reset it because of K. And you can't go any lower than low, so it just basically stays low. Reset again because of K. And then J is high, K is low, so we're going to set right there. Okay, that's because of J. So again, pause it, rewind it, whatever you need to do, and we'll go on when you're ready. JKs generally almost always have a asynchronous set and reset tied to them. That's what the SD and RD are, and they work exactly the same as they have been doing. If SD goes low, you got to set on Q. If RD goes low, you got to reset on Q, and the rest of it's the same. So let me get the highlighter out, and I'll kind of show you how I do this. This is how I remember how to do this. First thing I do is I figure out where my sets and resets are. The initial low you can put if you want to, just to remind yourself of it. But what I'm really looking for is anything past that. Well, this particular one has a set it goes low for this right here. So I just want to kind of remind myself that, hey, this is going to go low right there. Something's happening when this thing goes in yellow right there, right? And then that's the only time SD and RD goes low except for the very beginning. So I can do my positive edges. And go down here and do the positive edge for this one. And positive edge for this one. And I got positive edge. Well, the positive edge is through where SD is low. Well, remember, SD overrides the clock, so we really don't need to do this edge. It's not going to be seen by the flip-flop, so just skip that one. Then we got positive edge there and a positive edge there. That's why I do the SDs and RDs first, is so I can figure out what clocks I need to ignore. Now, once I've got it all highlighted, or dotted lines, or whatever you're using, now I can just skip from dotted line to dotted line without having to worry about, or highlighted area to highlighted area without worrying about what's going on in between them. So I need an initial condition. The reset tells me I'm going to reset the flip-flop. So that's because of RD. RD tells us we're going to start in a reset condition. Next, we've got two lows, which is just going to hold. And now we've got two highs, which is going to toggle. Well, if it toggles a low, it's going to go to a high. Low on J, high on K is going to reset. That's because of K. Now we've got this big highlighted area. What happened? Well, SD went low. If SD goes low, we set the flip-flop. And it's going to basically stay set all the way through to the next negative edge. That's because of SD. This one we've got a toggle because they're both high, so we're going to go low. And then we've got a high on J and a low on K that's going to set it high. So see, we can just kind of carry a hold from line to line to line, dotted line to dotted line, and not have to worry about, skipping around too much. Okay, let's do another example. Again with an SD and RD, so I'm a highlighter again. And there's an SD. Well, here's an SD right here. So let's look. We need to do something when these yellow areas come up. So that's a good way to remember it. And then we can go, since that's the only time they go low, we can highlight our negative edges. We're good at drawing straight edges, but it works. Now, can we figure out what the initial condition is? Sure, we've got an SD right there. It goes low. If SD goes low, remember we set the flip-flop. So we're going to be set over to there. And I'm not going to draw my line little letters up here. I'm just going to draw the waveform. Normally you don't draw the letters up there, but you can if you need to. So we set the flip-flop, goes high. We've got J is high and K is high. So it's going to toggle. Both high again, so it's going to toggle again. Both high, so it's going to toggle again. Low on J, high on K, so we're going to reset. Well, we can't go any lower than low, so that's it. We've got this big highlighted area means SD went low, so if SD goes low, it sets the flip-flop. And then we're two highs, so it's going to toggle. So that's what our output's going to look like. Now this is it for this lecture series, and if you need to rewind it, watch it again, read through the notes, and have the handout for you, and you can do some practice on that. That's it.